I'm going to compare this to n minus 1 over n 4 to the n. Anything in particular? Well, we know that that's going to be greater than. Do we want it to be greater than something, improve divergence, or less than something, improve convergence?
We want it to be greater than something, no, less than something, improve convergence.
Okay, so we know that this is, for example, less than, I don't know, n minus 1 over 4 to the n. Do we want to do that?
Yeah, n over 4 to the n. N over n 4 to the n.
Okay, you want to make you just want to get rid of that negative 1?
Yeah.
So you want to do this, like that? And what's that equal to?
1 over 4 to the n.
1 over 4 to the n, which is the same thing as 1/4 over 1/4 to the n, and we know that this is convergent. Good job. Sure. It says, if the alternating series, so you have a series and it's just going minus plus minus plus or plus minus. If it satisfies the fact that the next term is always less than the one previous. So it could be negative, it's definitely going to be less than it. But if it's increasing, if it's alternating and the next term is always less than the one before it, and the limit is going to 0, then it converges, which is more powerful than what we had before, because if it was just positive, does this hold? The harmonic series always gets smaller, right? Does it go to 0? Yes, but does it converge? No, but in this case, because it's an alternating series, if it alternates, it does.
So if you would make the harmonic series
alternate, an alternating harmonic series, guess what? It converges. It's kind of cool. It's kind of cool. Alternating harmonic, yay! Alternating harmonic does equal converge. That's nice. Convergent. But what about this one right here? Does this one converge? It is alternating. Why do you know it's alternating? Negative 1 to the n. So it is alternating, but what's the problem? What's the problem? What? Does it approach 0? Let's see if it does. Does it approach 0? Does it? You sure? The limit as n goes to, n goes to, you sure? N goes to infinity, rather, sorry. Or just 2 zeros there. Or just not being able to erase. That's even better. Does this thing go to 0? Does it go to 0? No, it goes infinitely. It starts going back and forth. It gets infinitely close to what? Yeah, it gets infinitely close to, on the left, on the above, it gets infinitely close to positive 3/4, and below it gets infinitely close to negative 3/4. So if you looked at this thing, here is, let's say that that's 3/4, and this right here is negative 3/4. What is this thing going to do? It's going to go do. It's going to get really, if they alternated. So it's going to look something like do. It's just going to get closer and closer. It's going to be symmetric, right? And it's going to get infinitely close here and infinitely close there. But the thing is, does it go to 0? No, it can't. It can't. So does this converge? So it is divergent. Are these actually connected up here? Like, are these? Is that something that's actually graphed? No, these are actually dots, and these are actually dots. I was just trying to draw a path. But it gets infinitely close and it gets infinitely close, so it does not converge. Yep. Does it look like it goes to 0? Yeah, the limit as n goes to infinity. And now one thing that's important to, so go back down here. So we're just looking at the limit as this goes to infinity. Does this go to 0? Yeah, it definitely does, because that cube goes big. So this goes to, sorry, goes to not infinity. It goes to 0. And what's the other thing it has to do? Each term has to be smaller than the one before it. So is it true that each next term, so n plus 1 squared over n plus 1 cubed plus 1, is that always going to be, how is that related to n squared over n cubed plus 1? We have to know about the size. This represents the term bn plus 1 right there. That's bn plus 1. And we want bn plus 1, and this is bn right here. We want to know the size relationship. If bn plus 1 is always smaller than bn. So look, you're making the top, you're squaring the top, but you are cubing the bottom. It goes bigger, faster. That 1 becomes kind of, so it looks like the bottom is becoming bigger. So does it look like it's getting, is bn plus 1 going to be smaller? Does it kind of look like it's going to be smaller? Suspect.
We suspect that it's convergent.
We suspect convergence. We do suspect it. We do suspect it. So we'll come back. See if you can. You're going to be less than S1, and then you're going to be greater than S2, then less than S3, greater than S4, so forth. It's going to go back and forth. So what do you get infinitely close to right there? Your actual sum, right? Your actual sum. So you're getting closer and closer and closer and closer. Do you remember Euler's method for, Newton's method for finding zeros? You do the tangent line, find where it hits the x-axis, then you drop the tangent line. You keep on going closer and closer. It gets really, 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 really close, and it keeps on getting closer. So you can use Newton's method to get arbitrarily close to a zero. And you might have answered questions like, get it to 5 decimal places. How do you know if you're accurate to within 5 decimal places? At least 5 decimals stop moving, right? Because once 5 stops, it can't get any worse, right? Once you've gotten, it can't never go outwards. The same thing is true here. You're always going inwards. You're always going towards your S. So the question is going to be, how far do you need to go in order to guarantee that you're within a certain distance of the actual sum? And there's a theorem that was really, really helpful and, again, I think really straightforward. And it tells us that, and remember, Bn is not the plus minus part. Bn is just the actual numeric part without the plus minus alternating. I hate it when that happens, I'm sorry. I'm not sure why it jumps that. It's kind of annoying, I know. If that is true and the limit as n goes to infinity of Bn is 0, then this is what it says. It says Rn is your error. It's going to be your estimate, like how close are you? Your like max error. Your max error is always going to be, so your max error is going to be what the actual value is subtracting what your partial sum is. So as you keep on going farther and farther, if you subtract where you are from what the actual value is, what you get is how far off you are. Does that make sense, everybody? You've done that before with like left and right hand limits. That is always going to be less than the next term. It's really cool. So if you have gone out to the 6th term, how close are you? You're as close as whatever that 7th term value is, which should kind of make sense because look at this picture here. If you go all the way to S3, the distance from S3 to S is always going to be less than B4, the next term. It's always going to be less than the next term. So if you calculated the 10th term, you know that if you figured out S9, S9 would be within B10 from the actual sum. So if you want to find, if I asked you a question, calculate the partial sums 10 decimal places, all you need to do is find the term in the sequence that is less than 10 decimal, it has to have 9 zeros. 10 zeros, sorry, 10 zeros. Does that kind of make sense if I do the hand waving kind of thing? So what does this say? It says right here, find the series correct to 3 decimal places. So what's the first term, Erica? If I plug in, what's the first term going to be? -1 to the what power? No, the first term starts at 0, so it's -1 to the, yep. -1 to the 0 over 0 factorial. By definition, hey, look, it tells you there. -1 to the 0 is 1 over, what's 0 factorial?
1.
So we're at 1. What is when n equals 1, what do you have? -1 over 1 is n equals 2. You end up with
1
over 2. And it keeps going. N equals, it's going to be -1 over 6. And you see the pattern here. It's going to be plus or minus 1 on top, and it's going to keep on getting bigger in the bottom. So the question is asking us, find the sum of the series correct to 3 decimal places. 3 decimal places, we need at least the first 3 decimals fixed. And we know the error can only be greater, has to be less than whatever the next term is. Whatever the next term is. So basically, we just need a calculator to calculate decimals here. Let's jump ahead a little bit, because we know we're not quite there yet, because 1/6 is definitely more than 1/1000th, right? So let's keep going here. Let's do like, I don't know, let's just jump a little bit and see how big it gets. Let's do, let's say n what? I think 10 too big. Let's do 8. Too big, and we're making it even bigger. Okay, so is it going to be positive or negative? So this is going to be +1 over 8 factorial. Can someone tell me what that is in decimal form? So that's going to be 1, 2, 3, 4, 5, like this.
1 over
So we have 1 over 8 factorial is equal to 0.1234248, right? So is that good enough? Yeah, well that's good enough because that tells us that this right here is the max error for max error for what?
For
S sub 7. S sub 7. That is the max error for S sub 7. So we can figure out what S sub 7 is, and that's the maximum error. Does that mess up 3 decimal places? No. At that point, you're definitely going to be locked in. The only thing else you check is you go back 1. So for example, I would just check this. It's not asking for a minimum set. It's just asking what are the first 3 decimals, right? We're not finding the least upper bound here. We're just trying to find what those 3 decimals are. So you know that if you figure out S7, you will be accurate to at least how many decimal places? At least 3. At least 3. So you could do S7 now. How would you do S7? Well, you'd have to do it out on your calculator.
Couldn't we just take S8 and say that?
We don't know what the sum is. We know that that's the maximum error for S7, but we don't know what S7 is.
So it's like
To get S7, we need B1 plus B2 plus B3 plus all the way up to B7 is equal to S7, right? And we know that S minus S7 has to be less than or equal to B8. And we know that that is equal to that right there. Does that make sense? So we know we're 0.00002 away, 0.00002 away, which is close enough. So if you took your calculator, could you do that and find out that decimal? Yes, you absolutely could. So what this means is, and I'll correct that right here, if the series converges when you take the absolute value of every term, it means that the series converges absolutely. So for example, what do I have there? 1 minus 1 over 2 squared plus 1 over 3 squared minus 1 over 4 squared. That's an alternating what series? What is that? An alternating? It's just an alternating series. That's all it is. And does it converge? Yes, because each term is smaller than the one before it. Correct? Yes. So it's getting smaller and smaller and smaller and smaller, ignoring the negative signs because it's just Bn. That's right. So this would be called absolutely convergent. Do you agree with that? This is absolutely convergent. Yeah, it's here. Yeah. So this right here we know is convergent. So the question is this convergent if we wrote it like this? If you made, instead of doing minus, then plus, then minus, then plus, then minus, then plus. We know this is convergent because it's an alternating series. Alternating, going to 0. But what happens if we took the absolute value? What about 1 plus 1/4 plus 1/9 plus 1/16? Is that convergent? It is. Yes, it is. Why? What kind of series is it? It's a p series. Yes, because p is greater than 1. Remember the p series? The n to the 1 over n to the p converges if p is greater than 1. Okay. Alternating harmonic series. The harmonic series itself, is the harmonic series convergent? No. The harmonic series is not convergent. But what about the alternate harmonic series? Is it convergent? It is convergent. Because it goes to 0 and it's alternating and every term is getting smaller. So it is convergent. So is this absolutely convergent? No, it's not. No, it's not, because look, we know that this, n equals 1 to infinity of the absolute value of -1, n plus, not n minus 1, because it turns it into, yes, look, because what does that turn it into? If you do the absolute value, it's just turning it into what? 1 over n, and we know that that is divergent. So in this case, this thing is convergent, but is it absolutely convergent? No, because if you take the absolute value of each term, it suddenly blows up on you. Here's what it says. You're looking at the limit of the n plus 1th term over the nth term, taking the absolute value of that. If that limit is less than 1, then the series is absolutely convergent and therefore convergent. If that limit is greater than 1, or it goes to infinity, then the series is divergent. And then if the ratio equals 1, then it's inconclusive. So you're doing a limit of the n plus 1th term over the nth term and seeing what happens. This essentially involves lots of algebra. That's it. It kills that flipping around -1, right? So what are we looking at? If we want to actually use this ratio test, we're looking at the limit as n goes to infinity of, it's the nth plus 1 term, right? So what's that going to be? N to the, no, not n to the, n plus 1 to the what power? 3 over 3 to the n plus 1 all over what? N to the third over, what's that going to be? That's the limit as n goes to infinity of n plus 1 cubed over 3 to the n plus 1 times what? 3 to the n over n cubed. Are you with me so far? So now when you keep this up, what cancels there? Well, 3 to the n, what's left on the bottom here? 3, and this goes away and turns into 1. And what's left on top over there? N plus, ooh, can we simplify this? You have to be careful, right? You just can't start canceling. So what do we have here? We end up with the limit as n goes to infinity of n plus 1 cubed over 3 times n cubed. What happens to that thing? What is that limit? What is that limit? What do you think? How do you prove what that goes to? What do you do? Okay. Well, no, don't. Let's just do it out and see what happens. You're almost there, guys. What does it go to? It's n cubed plus a bunch of stuff, right? And then over here, what is it? 3 in this, right? So what is this going to go to? 1/3. So let's go back and look here. If it's less than 1, what does it mean? Absolutely convergent. So therefore, is this convergent? Yes, which is less than 1, so convergent. Does that make sense on that one? Yay? Let's test the convergence of this thing. Nice. So we're looking at, you have to be careful, but a lot of things cancel on this one, which is really nice. The limit as n goes to infinity. It's always going to be positive, so do we have to worry about the absolute value aspect of this? No, it's going to be n plus 1 to the n plus 1 power over n plus 1, or n plus nothing apparently, n plus 1 factorial all over n to the n over n factorial. Well, that's going to be the limit as n goes to infinity of n plus 1 to the n plus 1 all over factorial times over, what cancels there? Well, this goes away, leaving you with just n plus 1. So you end up with a limit as n goes to infinity of n plus 1 to the n plus 1 all over n plus 1 times n to the n. Oh, can we cancel one of those n plus 1s? Yeah, sure. What does the top become? To the n all over n to the n. Now, what happens here? How do you prove what this goes to? You sure? You sure? This is equal to, you can be sure and be right, it's fine, I'm just having you justify. What do we rewrite this as? Limit as n goes to infinity of n plus 1 over n to the what? N to the n. So this equals the limit as n to infinity of n plus 1 over n all to the what power? N. You can bring, remember, you can bring powers outside of the limit. You can do the limit first. What does that go to? 1. So what do we know? Nothing. I think I found our problem. I think we made it. There's a problem here. Yeah, there's a problem there. Anybody see what the issue is? Oh wait, is there a problem here? What did we cancel to get from there to there? We canceled an n plus 1, right? We took out the plus 1 power. Yeah. Then it's to the same power on the top and bottom. Huh. Oh, I know what it is. You know what it is, kids? We have to be very, very careful about this. You ready to see? We're good to hear. Let's just be very careful. Does anybody recognize that right there? I'll rewrite it for you. Yeah, we got to be careful. What is this? What is that? Do you know what that is? On your calculator right now, plug in a huge number and tell me what that is. Just use your calculator. Tell me what that is. You've seen this. We know that this is going to E, so therefore its E is greater than what? E greater than 1, so what is it? Divergent. Yeah. Okay, thing right here. The domain is the set of all x for which the series converges. Notice that f resembles a polynomial. The only difference is that f has infinitely many terms. So this is just that's the same thing as me saying, what's the domain of this summation? So where is it convergent? So if we wanted to test this for convergence, what was that ratio? Well, I just told you. What was the test called that we just worked with? The ratio test. So let's look as the limit as n goes to infinity of the absolute value of n plus 1 factorial x to the all over n factorial x to the n. What's that going to be equal to? The limit as n goes to infinity of what? N plus 1 times x to the 1. So we know that if the limit as n goes to infinity of this right here if it's less than 1, what does that mean? Convergent, right? What's the only way for that to be convergent? What's the only way for that to be less than 1? Close, but n is changing. X has to be static.
Oh, 1 over infinity.
So make it easier. When is it definitely 0? Okay, when x is 0, this thing is definitely convergent. Do you agree? Right? Now what about for all other x values? For all other x values, what's going to happen? It's going to diverge. Exactly. It's going to diverge. For what values of x does this converge? So again, we'll use the ratio test. It's the limit as n goes to infinity of the absolute value of x minus 3 to the n plus 1 over n plus 1 all over x minus 3 to the n over n. And that's going to be the limit as n goes to infinity of x minus 3 to the n plus 1 over n plus 1 times what? Over to the n. Now what's that going to be? Yeah, it's going to be nx minus 3 all over what? Over n plus 1. Exactly. So we ask ourselves, and again, this is absolute value. So it's thank you. Right. Okay, so now how do we go about thinking about this? What's the top? If we wanted this to be less than 0, it's not less than 0, less than 1, it will converge. X has to be less than 1. Close. X minus 3 has to be what? Less than what? 1. So x has to be less than 4. So if x is less than 4, if we know x is less than 4, so let's say x is 2, for example. If x is 2, what's 2 minus 3? Does it matter that it's negative? No, it doesn't matter. And then you have n over n plus 1. Huh. Careful. Careful. We want this whole thing to be... What's the only thing that really affects the size of this? The x minus 3. So we need the absolute value of x minus 3 to be less than 1 right here. Yeah, what is that? If you want to do this on a number line, what does that mean? The absolute value of x minus 3 is less than 1, so it's all the things a distance of, like this right here. You see that right there? From 2 to 4? Or I could just put an open dot right here, like that. But if this is where it converges, and this is an interval notation, what do you think that interval is called? Anybody want to guess? The interval of convergence. It's called the interval of convergence. So if it's asking for the domain, what is it really asking you for? The interval of? The interval of? Yeah, they want the interval of convergence. And what are we going to use to find that interval of convergence? It is an alternating system. We're going to use the ratio test. It's nice to use because it means we can get rid of that dealing with the problem of positive, negative, positive, negative, positive, negative, right? So we need to look at what happens as the limit as n goes to infinity of, we can drop that negative 1, right? X to the n plus 1 over 2 to the 2 times n plus 1 factorial squared all over x to the 2n over 2 to the 2n n factorial squared. So that's going to be the limit as n goes to infinity of, yay, do you guys like writing this stuff out yet? No? I know, I was about to say I'm the one writing it. N plus 1 factorial squared, and what do we multiply that by? 2 to the 2n n factorial squared all over x to the what? 2n. So we have to be very, very careful about simplifying this. Let's work on this and this. Limit as n goes 2n plus 2, and it's 2n, so you get x what? X squared. So we just got rid of that and that. And then same thing kind of happens there, right? What are you left with? 2n and 2n plus 2, so it's going to be 2 squared. So we got rid of that and that. So let's keep going here. n plus 1 factorial squared and n squared. What's that going to turn into on the bottom? Be very, very careful.
That's n plus 1 factorial times n.
It's n plus 1 factorial times n plus 1 factorial, and on top you have n factorial times n factorial. So all the n factorials cancel, leaving you with n plus 1 squared. So you got a lot of squareds there, right? So now, is it a lot easier to do the limit? You have x over 2 times n plus 1 to the what power? To the 2. So if we want this to converge, we know that x over 2 times n plus 1 has to be, the absolute value of that has to be less than what?
1.
Less than 1? But here's the thing, n is going to what? Limit as n goes to infinity. Is there any way for x to keep that in check? As n goes to infinity, what does x have to go to?
Infinity.
Interesting.
And beyond.
So what do we think about this one?
Always.
Always what? Always what? Really? It's always convergent? If it's less than 1, if we can find an x value where this druid is convergent, can we? Can you specify an x value that guarantees that this thing will always be less than 1?
1.
Oh, yeah, you're right. I was thinking about the opposite way. You're absolutely right. I was thinking about it the flip side. The top is what you're fixing. The bottom is what grows infinitely large. You're right. So this thing is always what? Convergent. Good job, guys. Excellent. I can do all the hard stuff when it comes down to just like what happens with a fraction that gets infinitely big in the denominator. Fail, trip. What'd you say? Domain is?
R.
Domain. Domain. Very cool. What test are we going to run? Yay, ratio. Limit as n goes to infinity of, can we drop the negative 3n thing, or do we have to keep it in there? You can kick the negative out though, right? So what do we end up with? 3 to the n plus 1 x to the all over square root of n plus 2 all over 3 to the x to the n over n plus 1. So we flip that over, we cancel. So what do we end up with? We end up with the limit as n goes to of 3 to the what power? 1 x to the, so that cancels there, and then what gets kicked up here? The square root of n plus 1, right? N plus 1 gets kicked up here, yep. And what's on the bottom? And what happened to that? N plus 2, like this? So what does this go to as n goes to infinity? Does it go to 1? I think it goes to 1, right? Does it go to 1? Yeah, sure. We're tired. We don't really want to think about it too deeply, do we? So we think that this goes, the limit as n goes to infinity is 3x. So 3x needs to be
Smaller than 1.
smaller than 1.
So x is
So what is x between?
third.
And greater than?
Negative 1/3.
So we think that that's the radius of convergence. Yeah, that'll keep you awake. Find the radius of convergence and interval of convergence of the series. So at least it's telling you it is convergent. Again, what are we going to use? And write a big, big ratio. Yay, limit as n goes to infinity of n plus 1, x plus 2 to the all over plus 2. And I'm just going to flip it and do the same thing here. 3 to the over n times x plus 2 to the n. So what cancels here? What cancels? This goes away entirely, right? Leaving you with just? 3 on the bottom, right? Well, yes, 1 in the power. Okay, it's 1 greater, yeah. Now what about the rest? Oh, you have x plus 1 to the n over this. So this goes away, leaving you with just what? 1, you sure? It's n plus 1 times, and that's n times, so it's just 1. Very good. N to infinity of n plus 1 times x plus 2 to the first all over what? 3n. Oh, that's a parentheses right here. So what happens to this? What's the behavior of this as n goes to infinity? What does that go to?
1/3.
Goes to 1/3. So we're looking at 1/3 absolute value of x plus 2 has to be less than what? 1. So this, x plus 2, has to be less than 3. So the interval of convergence, x is going to be less than 5 or greater than 1. Very... Wait, no, wow, what are we doing? We got really close there. Really close there. So what does it center on? What's the center value?
1.
The center value is 1?
No.
1 or what? Negative what?
5. Negative 5.
Negative what?
Negative 5.
Is this right? There it is. There's your radius of convergence, your interval of convergence. We can do absolute values. Yay!